Okay, I'm kind of posting this early, so you really don't need to start working on some of the assignments until I post some next week. But we're going to be adding to this mix acid-base naming. First of all, I'm going to take care of the acid part. The base part is what we have been doing. So first of all, we're going to go with binary acids, which means you have the two elements. Your naming is going to change a little bit. We're not going to have the IDE, but basically what you're going to have is a hydrogen and some other element. And that some other element's going to be an actual other nonmetal. So first of all, we're just going to go ahead and name it. We have a template naming system, and it's going to be hydro blank ic acid. So I am going to assume that you have heard the words hydrochloric acid. You may know it's pretty strong, but this is how we're going to write the formula for it. We're going to have H and some other element. So let's say we have, for the naming, we're going to only go through a couple of them. Hydrochloric acid. That would be the naming system for it. The first thing I'm going to do is actually write the formula for it. First of all, I see acid, which automatically means I'm going to put an H. The charge of H is always a positive 1. That's probably the first thing you need to just kind of write. And then chloric comes from the word chlorine, so it's going to be Cl, and the charge of Cl is a -1. So we are going to write this like an ionic compound. Now if I kind of take a look at this, now I can reverse it. And what you need to do is write this part here and just fill in the blank. So we say, oh, acid, binary, hydro, ic, and then I put in this element. So it's going to be hydrochloric acid. It's kind of best to go ahead and just go back and forth from it because it kind of gives you an idea on what you're doing. Now let's go ahead and do another one. I'm going to again start with the name. I'll just put this in the box so it's not confusing. And then I'm going to put hydro, and let's go phosphoric acid. So when I'm doing this, your mind should automatically be trying to, figure out what you're going to be writing as far as this. And again, ionic naming system is the same as writing the formula for a binary ionic compound. I just automatically put H+. I'm going to use the symbol phosphorus. Phosphorus's charge is going to be a -3, which I pull off the periodic table. You're going to notice this is an unbalanced one, and I'm going to put a 3 here. And that would be the formula for hydrophosphoric acid. Now again, if I do the reverse, I see the H in the front, so I know it's an acid. I know it's two elements, so my frame's going to be hydroic, and all I'm going to do is put the element symbol where it belongs. If you practice it, this one takes a little less practice because it's easier to remember. Now on the ternary ones, you're going to have H, and we're going to also have something that's off your ion chart. So I'm going to put an ion chart. Now if you take a look at your ion chart, you're going to notice that there's ones that are going to end with ATE and ones that end with ITE. So if you're going to look at ones that end with ATE or ITE, it's a different naming system. So what we're going to do is, my first ending is going to be 8 that you see on the ion chart. This one, it's just going to be nice and simple. Just remember, you eat in the Nimitz cafeteria. I ate too much and I feel icky. So now 8 becomes ick. Ate too much and I feel icky. And then if you have a disease, for the one that ends with ITE, if you have a disease, in most cases it's going to end with us. So I may have meningitis. Well, that would be an ite-us. If I have bronchitis, ite-us. So again, we're going to kind of do right in the names. I'm going to kind of put it in 2 different columns. So let's say I have, in this case, sulfuric acid. The hydro's not in the front, so now I'm dealing with a ternary compound, or a ternary acid. If I see the word acid, I write H plus. I ate too much and I feel icky. It comes from the word sulfate. And if I ate too much and I feel icky, I have to use the sign for 8, sulfate, SO4, -2, because again, we're dealing with charges. And you always have to write the positive and the negative. And then I'm going to draw my 2 here because my negatives go under my positives, and I have to balance it out. So you do notice I don't put a 1 on the other side because that is a 1. And if I'm going to do the reverse and go back to the naming, you're going to say, oh, this has more than 2 elements. So I have to use the ion chart as far as the naming. This is going to be sulfate, which becomes sulfuric. That makes it an acid. So as you notice, the naming system is really not that bad, and the writing formulas, if you know how to write ionic compound formulas, then this is pretty easy. Now let's go ahead and do the other one. Let's go sulfurous acid. Okay, so if I'm going to do sulfurous, I'm going to be thinking ite-us. That's an acid. So I'm going to look at this as being sulfite. You don't have to worry about the UR part. So I'm going to have an acid with sulfite in it. Let's change that to ite. Oops. Apologize, lost concentration for a second. Let's go ahead and just make sure this is separated because that's what confused me. Now I have an acid with sulfite in it. Same procedure. I'm going to look for the sulfite symbol. I'm going to see the -2 charge. I'm going to see it's unbalanced, so I have to balance it. The negative goes under the positive, and I go ahead and I erase those, and that's going to be my formula for that one. Now let's go ahead and go to the other, well actually we've already done the other part, so we don't really have to separate it. Let's go ahead and do one more. Let's say I have something called chloric acid. Again, I see this and I have to automatically think 8-ic. It's an acid that has chlorate in it, so it's going to be H plus with my chlorate off the polyatomic chart with a -1 charge. If you notice, again, I don't pull numbers down, it cancels. That is my formula. Now let's do the other version of this, which is going to be chlorous acid. And I'm going to write H plus acid, ite, us, it's an acid with chloride in it, and then I'm going to go ClO2 off my periodic or my ionic chart, and it's going to be a negative. And that thing is going to be the same situation. It's going to be a plus and a minus. Just be careful with your wording and the eights and the ites. Now again, if I am trying to name it, I say, oh, 3 elements: sulfate, sulfuric acid, sulfite, sulfurous acid, sulfuric, sulfurous. This is going to be off the word chlorate. So I'm going to just change the A to ic, chloric acid. And then this one is chlorite. Then I have to say ite, us, chlorous acid. That's how you're going to name acids. Now let's really quickly go through the base part. Looks like my some of my stuff has been cut off. Hopefully it got all of it. If it didn't, just remember this one was the one that was H3P, and this one is the one that is H2SO3. And I apologize if it's cut off. It might have been. I can't tell. Okay, let's go ahead and do the bases, because the bases are kind of like the same as what we've been doing. In this case, it's always going to look pretty much the same. Let's go with a couple. Barium hydroxide. Again, I'm just going to go ahead and write the formulas because that's usually the problem area for people. And then let's say I go copper 3 hydroxide. This one actually causes problems sometimes with the formula writing. Again, kind of listen to what I'm doing. We have barium, which is the symbol Ba. It's in the red region, so it makes it a little easier to find it. And then I have the symbol hydroxide. You're going to notice it's a little bit different than hydride or oxide because they're all put together. So if I'm thinking oxide, it is an O, and if I'm thinking hydride, it is an H. If you do your charges like you normally should be, we're going to notice that this one is actually off the ion chart. That's how you're going to find it. That whole thing is a -1 charge. And then this one is barium, which is in the second group, a +2 charge. Now just remember, if I'm looking at that ion chart, I have to treat this whole thing as luggage. So basically, if I have a number other than 1 going outside of here, I'm going to have to put parentheses around it and put a 2. Now you may say or think that this is not anything different if I kept it without the parentheses. There is a huge difference between this one and the correct one. First of all, if we distribute my 2, I've got 2 oxygens and 2 hydrogens. In this case, I do not have 2 oxygens. So that one would actually be incorrect. If it cancels out, you don't have to worry about it. I'm showing ones that don't cancel out. So now in this one, I do my, writing the formula like I normally do. I have a +3 charge because it's given to me. So if I know the symbol of copper, I don't even have to look at the periodic table for the charge. It's given to me. And then I have hydroxide again with a -1 charge. And again, that OH is off the ion chart. We just refer to the ion chart as the luggage. It all has to go together. I have to put the parentheses around it because I have the 3. So it's going to look like this. Let's say I do one more, just to prove the point on the other one. Let's say I have potassium hydroxide, which is a very strong base. Again, red region, no Roman numeral, K. Hydroxide, symbol OH. I always have to look at the charges because I want to make sure if it cancels, I cancel it. If it's not, I write it correctly. Let's get rid of these charges here because they're no longer here. Now I have a plus 1 and a minus 1. Plus 1 and minus 1 equals 0. So what happens? They cancel out. So that is how you're going to write this type of formula for bases. Basically, they're all set up the same way. And you'll also notice I never put a number here because the charge on my hydroxide is always a -1.